Hello everyone, welcome back to my YouTube channel CSN IT Tutorials by Vrishali. In our previous some sessions, I have already covered all the important topics of data structure and algorithm subject with simple explanation, real life examples and practical demonstration. I have attached a complete DSA playlist in below description box. Now, in today's session, I am going to present your complete first unit, that is Introduction to Data Structure and Algorithm. This video will be helpful for your university exams as well as clearing your basic concept. Let's start the session. Previously, we have already discussed all these subjects in detail with practical demonstration. I have attached a complete subject playlist in below description box. Please subscribe my channel and also share this with your friends. That will be beneficial for everyone. Now, in today's session, we will discuss all these topics in detail with examples. This is the foundation of your data structure subject. Let's start the session. The first question is, why learn data structure? Why this subject included in your syllabus? One of the main reason is data structure improve your problem solving skill. Also, they improve your logical thinking. While doing coding, less time and less memory is required for the execution. How to decide this? So for that purpose, you should learn data structure subject. Again, in your final year, when you will apply for any interview or placement, whether it is product based company or service based company, data structure is the highest priority subject. Almost 60 to 70% questions have asked on data structure and algorithm. Suppose if you want to apply for any post-graduation degree like ME, MTech, MS, so for entrance exam purpose, again data structure is a highest priority subject. So you should learn accordingly. Now, again data structure improve your logical building. When you practice any other programming language like C, C++, Java or Python, but data structure is a base, it is a foundation of everything. If you are good in data structure, you should create feasible, scalable, faster and accurate application or website. That's why you should know the data structure. In data structure, you should learn about how to store data in different ways. Again, how to write algorithm, how to generate algorithms. You should learn everything here. In our real world applications, like in search engine, different Flipkarts, Amazon, then social media's application, gaming application, banking applications, Google Map, everywhere data structure is used. Basically, data structure is an essential and core subject in your curriculum. If you are good in data structure, you should get any advanced tech roles. That's why you should learn data structure clearly and accurately. So what exactly data structure? First we will understand what exactly data. Data means collections of information. Nowadays various types of informations have available on the internet. There are some numerical data, text, boolean, then multimedia, images, audio, video, right? So many and different types of data available on the net. So data means collections of different types of information. Now what exactly data structure? Data structure means to collect those information organized in proper and accurate manner. Basically, data structure organize, store and manage your complete information efficiently, which is called as data structure. What is the types and classification of data structure? As per your exam point of view, this is one of the most important diagram. See here, data structure have divided into the two types, primitive data structure and non-primitive data structure. Primitive data structure means built-in data types. I think you have already executed some programs where you have used integer, float, double, then a character, boolean, this kind of data types. So these data types are called as primitive data structure. On the another side, there is non-primitive data structure. Non-primitive is the user-defined data structure. It has divided into the two parts, linear and non-linear. Linear data structure means your all information have stored in sequential or in linear manner, like array data structure, linked list, queue and stack. This data structure support the linear data structure functionality. Nonlinear data structure means all the information have stored randomly or in hierarchical manner. Trees and graph. This data structure supports nonlinear data structure functionality. So these all are the types of data structure. Next question is, what exactly difference between linear and nonlinear data structure? As per your exam point of view, this is one of the most important question. Let's see the difference. See here. Linear. The name suggests that all the information, all the elements have arranged sequential manner in linear one by one, right? This is called as linear data structure. See here in these images, here stack of books means all the books are arranged one after another sequentially. Here queue of particular supermarket or shopping market. So which is called as linear data structure. Now, in non-linear data structure, all the information, all the elements have arranged in hierarchical or interconnected manner. See here in this diagram, these are the tree, these are the graph data structure. All the nodes are connected with each other, like Google Map. Google Map is the best example of non-linear data structure. There are multiple nodes, multiple like source, destination, they are connected with each other, right? Now, in linear data structure, they stored all the information at the single level or in one dimensional format. We can implement linear data structure by using array or linked list. But in non-linear data structure, all the information have stored in multiple levels. See here, that is level 0, level 1, level 2. Means all the nodes are connected with each other at multiple levels, which is called as non-linear data structure. Again, these are the some examples like array, linked list, tag, queue. These are the examples of linear data structure. And trees and graph are the examples of non-linear data structure. Basically, linear data structure is very easy to implement and manage. They are more memory efficient because they stored all the data in sequential manner. But on the opposite side, nonlinear data structure is very complex to implement because they use the concept of pointer. One node points to the next location, next node. So, it is a very complex structure and more memory efficient. They require the more memory. Linear data structure generally suitable for some simple and ordered data like sequential data. But nonlinear data structure is suitable for hierarchical or networking data. So this is the basic difference between linear and nonlinear data structure. The next difference is between static versus dynamic data structure. The name suggests that static means fixed size of data, and dynamic means variable size of data. You can add as many as information in particular data structure. The best example of static data structure is array. Array always have a fixed size. You can't shrink or grow size of the array. The best example of dynamic data structure is linked list. In linked list, you can add as many as node or as many information as per the requirement. You can grow or shrink size of the linked list at any time. So which is called as dynamic data structure. That's why static data structure is very easy to implement because they have a fixed size. But dynamic data structure they required the more complex because the size is not fixed. They required more pointers, more memory references. Static data structure is a faster speed because they have a fixed size and less overheads are there. But dynamic data structure required the slower speed. They required more memory allocation, pointers, because pointers points to the next address of particular information. So they required more memory and more pointers. So that's why their size is slow as compared to static data structure. So this is the basic difference between static and dynamic data structure. The next difference is in between persistent and ephemeral data structure. Let's understand with example. See, first there is a persistent data structure. As per the definition, persistent data structure kept previous version as it is after the updation. I will give you one simple example. Assume that there is a WhatsApp application. WhatsApp application has total two features. First, chatting, and second, status uploading. So this is called as alpha version. Now after some days, there will be some updates in WhatsApp application. Now again they add two more feature. First video calling and second audio calling. So at that time WhatsApp application take previous features as it is and again add new features in that, right? This is called as persistent data structure. They kept previous version as it is after the updation. So on the opposite of that there is a ephemeral data structure. Ephemeral data structure does not retain the previous version after the update. That's why persistent data structure they exist multiple versions and that's why the memory usage is more. But ephemeral data structure they kept only latest version, only latest features. That's why their memory usage is less. Persistent data structure having the faster speed as compared to ephemeral data structure, and persistent data structure is very complex to implement as compared to ephemeral data structure. Again, we will understand same concept with different examples. See here, in persistent data structure, the best example is Google Docs. In Google Doc, auto save functionality is there. They by default save your data. Again, chat history. Your previous chats are as it is in particular chatting application and you will add your new messages there, right? Bank account transactions, undo redo functionalities. So these all applications kept your previous data as it is and add the new data, new information there, which is called as persistent data structure. Now, in ephemeral data structure, the best example again is online shopping cart. See, you can store different models or different products in your shopping cart, in your Flipkart, Amazon application. You can add and remove this cart anytime, right? So this is called as ephemeral data structure, like in stopwatch, timer, or GPS tracking. Live GPS tracker gives the live's information. They can't store your previous location information, right? So this is called as ephemeral data structure and this is the basic difference between this. The next topic is abstract data types. First we will understand the concept of abstraction. Abstraction means it shows only essential information to the user and hide unrelevant information from the user, which is called as abstraction. Let's understand with this some real life examples. I think you all are doing the chatting by using WhatsApp application. So you are sending the messages continuously from multiple users, right? But you don't know about how this message will be sent from one user to another user, right? You are directly using the particular functionalities, but you don't know about the logic, the structure behind this. So this is called as abstraction. Again, while driving a particular vehicle, you know that when you apply a brake, your vehicle must be stopped. But you don't know about how this brake was developed, right? So, particular company, a particular organization, they shows only essential information. They hide all the background, all the irrelevant information from the user. This is called as abstraction. Similarly, in data structure, there are multiple abstract data types. See here, these abstract data types organize your information and also display what operations can be performed without focusing on their implementation, which is called as abstract data types. In stack data structure, we are directly using push, pop, pick, this kind of operation. Like push used for insertion, pop is used for deletion, and pick to fetch the topmost element into the stack. Again, queue data structure having multiple operations like enqueue and dequeue. So these are the built-in functionalities. They by default perform the insertion and deletion. So this is called as abstract data types. Means you are directly using that functionalities. You don't know about their behind or backward work, right? So this is called as ADT, that is abstract data types. Now The next question is, what exactly algorithm? Algorithm basically means step by step procedures. It is a set of rules to solve the specific problems. In our real life, we are using algorithms everywhere. If you want to make a tea, you are using a proper particular procedure, right? If you want to drive a vehicle, you are using a proper rules, proper steps, right? So everywhere we are using the concept of algorithm. So while doing coding or while doing programming, so the first step is algorithm. You have to write down the algorithm steps, and after that this algorithm sent forward to the developer or programmer to develop a particular application. So basically algorithm means step by step procedure, step by step instructions of particular applications. Now the most important question is, why learn algorithm? The first thing is, by learning algorithm, you can improve your problem solving skill. You can improve your logical thinking, right? You can solve any problem more efficiently. Again, every code you write is based on the algorithm. If you want to do programming in any language like C, C++, Java, Python, but base is the algorithm. First, you need to write the algorithm, then only you will move forward to the coding. Again, it improves the logical thinking, your problem solving approach. Also, it helps in your competitive coding and interviews. Some companies, they have their aptitude round, technical rounds are there, right? So algorithm is a key part of every technical round. If you know the algorithm, if you know the problem solving approaches, then only you should do the coding and programs. So this is the base of everything. Again, we can use algorithm in our real life for every application like social medias, then food ordering system, hospital management system, bank reservation. Every application, every website, they have their own algorithms, own procedures. So that's why you must learn algorithm. This is the base, this is the foundation of everything. So algorithm means set of rules, set of procedures. The next topic is properties of algorithm. So these six are the main properties of algorithm. If you follow these properties, then only your algorithm will get the accurate result. See, the first property, which is called as unambiguous, means whatever the input and output of particular program must lead the only one meaning. While doing addition program, so there are total two inputs are necessary, right? Suppose 2 plus 2, so plus indicate the addition, the output is 4, means input and output must lead the same meaning, which is called as unambiguous. Again, while doing the chatting by using WhatsApp, so you are sending the messages continuously, so continuously sending messages to the actual contact number, actual person, means input and output must lead the same meaning. So which is called as unambiguous. Next one is input property and output property. So while doing coding or any other programming, zero or more inputs are compulsory, and after getting the result, at least one output is compulsory, right? Without input and output, you can't execute your program, right? So these two are the most important properties of algorithm. Next one is a finiteness, means your algorithm has finite number of steps. Your algorithm has proper start and proper stop. Your algorithm didn't goes to the looping condition, right? So this is called as finiteness. There are proper starting and proper ending. Next one is a feasibility, means your algorithm is feasible to every other available resources. Some users use the Windows operating system, again some users use the Linux operating system. But if you want to execute your particular program, so your algorithm, your program is feasible to the all available software or hardware resources. So always write the program accordingly. And next one is a independent, means every step, every module or every instruction in your algorithm works separately, or you can modify it at any time. So these six are the most important properties of algorithm. As per your exam point of view, this is one of the most important question. Next topic is algorithm design strategies. Algorithm design strategies always give you a how to generate and how to write algorithms in different ways as per the problems, as per the requirement of the user. Here I am giving you a complete overview on different algorithm design strategies. Let's understand with the example. See, the first algorithm design strategy is divide and conquer. The name suggests that if you have a big or large number of problem, so divide your problem into the smaller parts. Apply or find out the solution on them and after that merge it. So this is called as divide and conquer strategy. See here, there are different photo editing application or video making apps are there. They use the divide and conquer strategies. If you have a two or more videos, so you can merge these videos. After that you apply music in background and again you apply filtering options are there. Means you apply different functionalities on the smaller parts and after that merge it. So this is called as divide and conquer strategy. The next is greedy algorithm. So greedy algorithm design strategies always find out the best possible path to your application. Let's take an example of Google Map. Google Map always give you a shortest path from your source to destination, right? They will give you a accurate path, whether there is a traffic or not traffic. They give you a everything in detail. So this is called as greedy algorithm to find out the best option at every step. Next design strategy which is called as dynamic programming. So dynamic programming design strategy stored your previous result and apply or use this result for your future purpose. Let's understand with your example like keyboard auto correct. See, when you type something on your mobile, suppose you are giving your Gmail ID to particular person and when you type your Gmail ID, they automatically suggest this thing, right? When you type any particular keyword like suppose structure, so st, when you type s and t, they will give you a complete word like structure which is called as autocorrect, right? So this is called as dynamic programming. Means you have used this word, you have used this your Gmail account previously, right? So they stored their result on the keyboard buffer and use it as per your need. Again, next example which is called as text prediction. When you search something on the Google, so when you type just S, so they give you all the results when you already searched previously starting with S, right? So which is called as dynamic programming. They store and reuse your data and information. Now the next design strategy which is called as backtracking. Backtracking means if you want to work on particular project, if a particular logic or particular condition doesn't match, you backtrack it, right? This is called as backtracking. Backtracking concept generally used in multiple online gamings like solving puzzles. While solving puzzles, you add a particular number, a particular character. After that, you got it that the particular character is not correct. So you take a backtrack it, right? So different Sudoku, undo redo functionalities, they use backtracking applications. Next is brute force algorithm design strategy. So generally, brute force algorithm design strategy used in cyber security domain. Basically, if you want to try all possible options until your answer is found. So for that purpose, they use brute force design strategies. Let's take an example of password cracking. Suppose there is a particular hacker. Hacker want to hack your mobile by using your password. So they try multiple times. They try multiple possible options for cracking your password, right? So this is called as brute force design strategies. Now the next one is called as randomized algorithm design strategies. So randomize, the name suggests that you can use random choice to solve the particular problem with many possibilities. The best example is OTP. Every user get random OTPs in their mobiles, right? Again, there is a captcha option that is security purpose. So which is called as randomized design strategies. So as per the user requirement, as per the user's project, developer decide the algorithm design strategies and develop a particular project accordingly. The next topic, which is called as performance analysis. While generating or while writing the algorithm or while doing the coding, performance analysis matters a lot. So how to do this performance analysis? There are two ways. First, to analyze your program by using time, that is time complexity, and to analyze your program by using the memory, means how much memory is required to store a particular program, which is called as space complexity. So this time complexity and space complexity choose the best algorithm for your project and for your problem. So overall performance analysis is done by as per the time and as per the space required for your program. Now let's understand in detail. So the first topic is what exactly time complexity. So basically time complexity means how much time is required to execute a particular program, which is called as time complexity. Now there are multiple factors which is affects on the time execution of your program. See, first there is a input size, means how many number of input you have passed to your program. So as per that also time of execution is dependent. If in your program there are total 2 number of input and on the another side if in your program there are 1000 number of inputs you have to pass. So obviously 1000 number of inputs have there, means time required for execution is more. But if there are only 2 number of inputs have there, so time execution is faster. So input size is one of the main factor to decide the time complexity of your program. The next one is a algorithm design, means how many logic, how many loops, nested loops and conditions are in your program. So according to this also we need to decide the time execution of your program. Again, recursion and calls, means how many time function callings are there. So these all factors are necessary to calculate the time complexity of your program. Next topic, which is called as asymptotic analysis and notations. So before understanding this concept, I am giving you a one simple example. See, if you want to calculate the temperature, which notation is used? We have used degree Celsius, right? Or if you want to calculate the speed of particular thing, which notation is used? We have used kilometer per hour, right? So similarly, if you want to execute your particular program or if you want to calculate the how much time is required for executing your program. So for calculating time purpose, we are using different notations. And these notations which is called as asymptotic notations. Notations like omega, theta and big O. Similarly, how much time is required to execute your particular program. So we can analyze this thing by using three parts: best case, average case and worst case. Now let's understand in detail. What exactly best case? So if you want minimum amount of time to execute your particular program, which is called as best case. Best case always give you a faster performance and which was indicated by the omega notation. Similarly, if your program required maximum amount of time for execution, which is called as worst case. Worst case always shows the limit of your performance and worst case always indicated by the big O notation. Same, if your program required expected amount of time or typical time for execution, which is called as average case. Average case always display the realistic performance and average case indicated by the theta notation. So this thing which is called as asymptotic analysis and notation. Now again let's understand with this simple example. See, suppose there is a one array and these elements have stored into the array. If you want to search two elements in particular array, see here we are using here linear search concept. In linear search, we are compare element one by one sequentially, right? Here we need to search 2. So first you compare 2 with this first element, right? So 2 exactly 2 means your key element is found. So in minimum amount of time searching is done. So which is called as best case. Again, in the same example, if you want to search the element 5, so how many comparisons are required? First 5 compare with 2, then 6, then 12, again 1, then 90 and then 5. So 5 is exactly matched with 5 here. Means they required maximum amount of time to the searching. So which is called as worst case. And in average case, suppose you want to search other than start and end of the element. So which was displayed by the average case. So this is a basic example of best, average and worst case. Now again I am giving you a real life scenario regarding these cases. See, let's take a scenario regarding login authentication. If you want to open a particular website or particular application, you are typing a particular password, right? So in first attempt, your password is matched. So which is called as best case. Means in minimum time, you are opening a particular application, your password is exactly matched. This is called as best case. Similarly, if you want to try multiple attempts or multiple attempts are fail while typing a particular password. So sometimes what happen? Your password typing limit is reached is there, right? So after multiple login fails, your application goes to worst case because you required maximum amount of time for opening a particular application. Clear? And suppose if you required 2 or 3 attempts, maximum in any other application or website, 3 attempts are there, right? So if you required maximum 2 or 3 attempts for attempting a particular password, so which is called as average case. So this is a real scenario that we are using in our daily life. So that is best case, average case and worst case. Clear? Now, where these applications have used? So best case generally used in safety critical systems like in heart monitor system. In hospital, there is a heart monitoring system. So heart monitoring system always give you a real time data, right? So which is called as best case. In military, in defense system, they use the best case because they require the real and on time data. Again, if you want to require a particular project that has some realistic estimation or realistic projects is there, which is called as average case. Again, if you want to build a particular application in safe design, that is limit of particular performance, which is called as worst case. Again, the another example of this, sometimes what happen, due to some networking issues, a particular website take a too much time for loading purpose, right? So how much time is there required for loading? This is called as limit of particular performance of that website. So this thing is called as worst case. So this is a asymptotic analysis and notations in time complexity. As per your exam point of view, this question is important. Now, the next topic is asymptotic analysis. Here, I am giving you a diagrammatical representation of this thing. See, I think you know about now best, average and worst case, right? So why do we use all these 3 cases? First, best case, if you want to require fast execution or if you want to require the real time data. So at that time we are using the best case. The best example is autocomplete search. When you search something on Google or when you type something in Microsoft Word or any other IDE, any other programming IDE, they autocomplete the sentence, they autocomplete the word, right? So which is called as best case. See here in this particular diagram here. So, okay. So here f of n. So f of n indicate the number of inputs given to the particular program. So f of n perform fastly as compared to Cg of n. Cg of n is any other logarithmic equation. Okay. So f of n is faster than Cg of n. See? So this thing is called as best case. Again, the next is average case. Average case generally represent a real life performance. When you search something on any other shopping application like Flipkart, Amazon, you applying some filters, again remove those filters, apply some new filters are there as per the requirements. So which is called as average case. See here in this diagram. So f of n is as similar to Cg of n, means they require the matching performance, which is called as average case. Again, the next one is a worst case. Worst case generally ensure the reliability, or they check the stress testing or system testing of your application. So which is called as worst case. See here in this diagram, f of n, that is function of n, number of input is large. So their performance is slower as compared to Cg of n, right? So they indicate the worst case of your program. So which is called as asymptotic analysis. Now the next question is analysis of programming. So there are multiple types of time complexity, and time complexity notation is dependent on which type of program you have executed. How many loops are there, how many comparisons are there, which type of data types you have used. So everything, every metadata is matter to analyze your programming, right? See here. So these are the some multiple time complexities, that are the some common constant time complexities as per your program. See, if in your program there are constant variables are used like constant pi, constant a. So for constant variable purpose, the time complexity of that program is big O 1. By default, we are using the big O notation for calculating any time complexity, right? See, that is big O 1. Let's take an example. Suppose you switch on the light. So switch on, this is a constant part. So this type of programming purpose, big O 1 time complexity is needed. Next is logarithmic program. Logarithmic program means like binary search. In binary search, you divide your complete program or complete problems into the smaller parts, right? So for this purpose, which is called as big O log and time complexity, means you divide your data in smaller parts, again divide your data in this some sub parts, right? So this kind of concept, which is called as logarithmic concept. So where you can use big O log and time complexity. Next one is a linear time complexity. Linear means, let's take an example of linear search algorithm. If you want to search a particular data, you want to start the search from first element to last element. So which is called as big O n. Means n number of elements are there and you are searching for the all from first to last. So linear search algorithm always having the time complexity big O n. Again, there are some efficient algorithm. If there are some algorithms are used on large scale database like merge sort, quick sort, these algorithms are used on large amount of data. So for that purpose or for efficient performance purpose, the time complexity is required big O n log n. The next one is a quadratic like bubble sort or nested loops. If in your program there are total two loops are there, let's take an example of bubble sort. So while implementing the bubble sort program, there are total two loops. First loop indicate the passing, how many passes have generated, and second loop indicate the comparisons. Means there are total two loops, and comparisons always is from start to end. So this quadratic algorithms, the time complexity is big O and square. Means in first loop they goes to start to end, and second loop again they goes to start to end, that is up to n and n. So n into n equal to n square, so which is called as big O n square. Next one is exponential growth. If your program is related to the Fibonacci series or recursive operations are there, so their time complexity is big O 2 to power n. Again, if you want to do the programming related to the factorial concept, if you want to solve the particular puzzles, means many times you have trying to possible multiple options are there, right? So for that purpose, the time complexity of this scenario is big O and an exclamatory sign. So this is an analysis of programming. So as per this growth, decide the time complexity of particular program. Now, the next topic, which is called as space complexity. Space complexity basically means how much memory is required for storing your particular algorithm and particular program, which is called as space complexity. Again, there are multiple factors to calculate the space complexity or to calculate the memory execution of your program. See, the first and most important factor is input storage. How many inputs you have passed to the particular program. So which is called as input storage. So this is one of the most important factor. Again, data types. Which type of data types you have used in your program, like integer, character. So character required a 1 byte of memory, integer required a 2 byte, float is required 4 byte, again double is required a 8 byte of memory, right? So data types, how many and which type of data types you have used in your program, this factor is also affects on the calculating the memory. Next, how many temporary variables are there, how many function calls are there, and which type of data structure you should use, whether it is stack, queue, linked list, tree or graph. So these all factors are necessary to calculating the amount of memory is required to store a particular program, which is called as space complexity. Now, the most important question is why space complexities matter. See, first I am giving you a one simple example. When you download any other application from the Google Play Store, suppose when you download WhatsApp application from Google Play Store, so Google Play Store shows the size of that application. They shows the size whether it is 19 MB, 20 MB is there, right? So this is a memory. This is the actual memory required to storing a particular application. So if there is a less memory, that's why your app or your website is more correct. So in data structure, less memory and less time is required for the execution. See, the first reason is efficient memory usage. Nowadays, 4 GB, 16 GB, 32 GB RAM is there in your mobile. So this is a responsibility of developer. This is a responsibility of analyst. A particular application is suitable to every other devices, every other your mobiles, laptops and computer. So for efficient memory usage purpose, space complexity matters. If if your RAM size is 8 GB, right? But your particular application required 50 GB of data. So which is not suitable, right? So sometimes what happen? They slowing down your memory or sometimes crash the particular system. So that's why efficient memory usage is compulsory. Now, the next reason is scalability. See, multiple users are access a particular website at the same time. So load handling, this is one of the most important concept while creating or developing a particular website. So at that time, for scalability purpose also, space complexity matters. I am giving you a one simple example. See, suppose there is a Flipkart application. I want to buy a particular laptop. So I am applying a particular filter. Whether laptop which is HP company, then laptop price is less than 1 lakh, then their model, again their color, again their size, right? So we are applying different types of filters. So this data have stored into the temporary memory in temporary usage. Again, another customer, another user apply different filters. To storing all this type of data purpose, your program, your algorithm is most scalable, right? So scalability is an essential or main factor in space complexity. Now, next one is a faster execution. Obviously, you required every features is executed fastly, more efficiently. You all are using WhatsApp functionality. So chatting, video calling, audio calling, status uploading, every features work fastly within a second. So which is called as faster execution. Faster processing is there. Again, in and infrastructure cost. See, nowadays companies having the large amount of data and they store their data on different platforms like AWS, Azure, then GCP, that is Google Cloud Provider. So companies store their data on these cloud platforms. But these cloud platforms are not free, right? They apply some charges to that particular company to store data temporary on that cloud, right? So this cloud platform provides different storages, virtual machines and database for storing the data. And they apply the charges as per the CPU hours, storage allocation means how many size of data, and data transfer charges. So according to this factor also required less memory for particular app or particular website. So these factors are necessary. That's why space complexity matters. Again, as per your previous year question paper, these are the some important questions that have asked in your in-sem exams or university exams. Like define data structure and data objects for 4 marks, difference between linear and non-linear data structure, then explain linear data structure with examples for 4 marks, difference between static and dynamic data structure. If any difference question asked for 4 marks, so you have to write down mostly 5 points there with example. Then explain abstract data types with example, importance of algorithm analysis and design strategy, what is space complexity and their importance, right? So in importance, you need to write down why space complexity matters. Then what is time complexity, again their importance. And you have to explain all these asymptotic notations with example. So I have already provided the simple linear search example and login authentication scenario. So prepare all these questions accordingly, accurately. So this is all about. Stay tuned. In my next video, I am giving you a complete one shot on second unit. Thank you. Keep learning.